Hi. Well, we are going to be starting today. Happy Halloween, everybody. Hi, happy Halloween. Hi. Today, as a commemorative day for Halloween, we are having, for the first time, a new introduction video that was made by an artist for us in more than 3 months of work. So the video today changed, and I'm going to show it to you, and I think some people here that also didn't see it. Thank you very much. That was done by Fermín Valeros, and he worked a lot for this. Fermín, if you are watching this live, thank you very much. It's going to be our new introduction video from now on. So now that we are here, let me welcome you. Welcome, everybody. Welcome. You are here with us. Happy Halloween, people. Happy Halloween. So as you saw, we have some new people with us, new characters. So who wants to go first to the rundown? There you go. Bravo! Do you want to say something? You cannot say something. Be careful. Anything, she will kick you out of the place. Who wants to go next? Oh, there you go. Bravo! Are you sure he was doing that one? If you don't know who he is, you need to search more on the internet. There you go! Bravo! It's Saruman, right? Oh, that's such a bad place to say that one. Bravo! And let's go! Bravo! If you don't know who he is, guys, you need to read more books. There you go. Yes, and we have people here. Oh, look at that. Thank you. Where is there you go. Wait. We have people. You cannot see them internet, but we have people Halloweening with us. Yes. I hear. Oh. If you are wondering, I'm a Dragon Rider Mafia Gangsta. It's a new movie from Disney that is coming soon. You will see. Italians and Dragon Riders are coming. Okay, so let's start with the class today. We have a lot of stuff to do. Today, we also, in case you didn't notice, we also adapted the document for having scary fonts in this document. I know that is Comic Sans. I know, I'm sorry. I'm playing with your feelings. Don't cry. Don't run away. But, ooh, yeah, I know. It's the season, people. So today we are going to have privilege escalation, persistence, side channel attacks, okay? October 30, so technically tomorrow is Halloween, but there you go. And credits for all of them, including the new introductory video for Fermin Valeros. We have all the links. I think we also have some couple of new links that you can find them later. And we are going to start with the results from the survey of the last class. Before starting, I want to check the streaming and the internet. Are you there, internet? Yes? We have everything? Perfect? OK, there you go. So, how was the last class? How did you like it? The honeypots with Murray's? Yes? No? Yes? A little bit? Super duper? There you go. Internet, did you like the honeypots with Murray's? It was a nice class, and I'm glad you took it. And later in the year, we are going to have each of us giving some classes. So we are going to have to listen to all of us. And in case you didn't notice, that pumpkin there, it's putting out smoke. Ah, what? And you can go and check it out later. It's you can believe that inside there is some water. No, 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 it's magic. Yeah, you can check close later. So, results from the survey of the last class. Last class, the pace was okay. And for some of you it was fast, for some of you were slow. So we are expecting a little bit of this percentage. So we are going to keep roughly the same pace. You were able to follow the teacher, what was planning in class. Yes, most of you, yes, with 5s and 4, and some people don't. Please remember to click on the feedback every class, and so you can tell us about it. Even if you believe that there is nothing to change, you can go there and give feedback about it too, because we have nothing to keep improving if not, okay? So, then we have the Pioneer Prizes. So, Pioneer Prizes for assignment number 6 last week. Do you want to say something, Gandalf, Saruman, Radagast? I'm a little bit lost about who you are.
Nothing special. Like the first 2 places were 5 minutes apart, and then third place was 20 minutes behind them. Very nice, all in all.
Okay, so if you didn't, sorry?
Not too fast, not too slow, just nice.
Perfect. If you didn't play the assignment yet, I'm not going to spoil it, but it was very nice, of course, related with honeypots, so you can go and take it. Something about the previous webpage that you sent, you want to say something? Not? No. OK, later on we are going to tell you about what was that about. So, Pioneer Prizes. We have the third place. It's an ASP8266D1 Mini with Wi-Fi, a development board for hacking, and the third prize goes to Zahorto 2. Well done, Zahorto. Be careful with the dragon. Don't get close. Don't. There you go. Sure. And the second place is a smart RGB bulb with Wi-Fi. It's the definition of IoT, things that you can control with your phone. Extremely weird and dangerous, so there you go for you. And the second place goes to Kupkayan. Bravo. Where is Kupkayan? Not here? Oh, no. Kupkayan is not here. So what are we doing? Kupkayan, you have 2 hours, 50 minutes to come to the class, or we will see. And it will be quarantine, I'm translating to you before that. And the first place goes with a Raspberry Pi 2 Pico 2 with Wi-Fi with 2. Holma! Bravo, Holma! AKA the skeleton. Well done there. So, Parish notices for this class. Assignments 1 and 4 will stop on the midnight of 30. So if you are missing some of the assignments 1 to 4, tonight is the last moment you have to submit. or you're going to be losing the points, okay? Online students, internet, that's you. Make sure you put the changes and start class number 6 now. It's going to be fast, but just in case. And also for all our online students, we put here, oh yeah, it's also start class 6. I want to delete this. 2 things that you need to install. We are going to be doing this later, but in case you want to gain some time, you can start installing right now, okay? So that's all. No more Parish notices, nothing extra. Something from the internet. No, I cannot rotate a lot, so. Internet, no, we are fine? Okay, perfect. So this class, we are going to have side channel attacks, gaining persistence, privilege escalation, and staying under the radar, okay? Roughly, those are going to be the topics. If you remember, we were attacking computers remotely, we were gaining access, then we were defending the computers, including last class, installing honeypots, and using deception to kind of stop the attack. So now we are going to go back a little bit into the attacking side and the defending side, and we are going to be actually trying to improve our attack by gaining persistence, like going into being root, let's say, or administrator, and how we can hide our tracks, okay? So that's going to be roughly the topics today, with a little bit of defense. So, side channel attacks. Who can tell us for a cookie, not a cookie, chocolate, what is a side channel attack? Wait. There you go. Who can tell us? Side channel attack, people. Side channel attack. Wait for me. Beep, beep, beep. There you go. 1, 2, 3. Hop.
Is it one of those where you can attack the computer from kind of unexpected or unintended ways, like observing the rising of temperature from the computer or from the, I don't know, processor, or how it's heating up and down or whatnot?
Okay, do you agree with this definition? Like attacking computer from unexpected things like temperature, or you say something more, I don't remember.
No, just more.
That temperature. You agree? Something to add? No? Okay, there you go. I need a gun for today, right? Like dropping like this should be like, freeze! No, freeze is police. What do the gangsters say? They just shoot you. So I'm gonna just, there you go. Side channel attack is a type of attack where we are extracting this information, secret, because it's a password, it's a database or something that should be there, from a system by observing indirect signals. So the key part here is that the signals are not the data directly itself. You are not trying to brute force something and get in, but actually you are analyzing indirect signals that the system is producing. So not by breaking, let's say, mathematically the cryptography, but measuring what we call unintended leakage of data, like temperature, time, power, emission, sound, cache behavior, and others. So these are incredibly powerful techniques. We are going to be seeing today some of those, and they are extremely hard to stop. Once you have one of those, it's kind of hard to stop it, right? I'm not going to say impossible, I'm going to say very hard. So this is one way that you can actually attack a system that is completely new up till now for us. So types of side channel attacks. The first one is electromagnetic. Electromagnetic means that there is a type of key extraction. When we say key extraction, we mean usually the production of cryptographic keys in computers. If you read about this, the majority of the times, what's happening is that the computer needs to generate cryptographic material, and in that moment, the moment the CPU is creating the cryptographic material, you can actually try to know what the computer is doing, okay? So in that case, it's extracting emissions from a computer CPU, for example, while it performs encryption, or even the radiation going out of this, right, can reveal patterns that allow the attacker to deduce cryptographic keys. There are many, many examples of this. I think that the most famous one, or the first one, was in the 80s. There was an attack called the Tempest attack. And if you remember, in the 80s, instead of these LED type of monitors, we have monitors that are emitting with an electromagnetism field and some magnets, photons into a display, right? The old TVs, the old monitors. So what happened is that when you have a monitor and you have like photons going into the screen, you can actually analyze the electromagnetic signal that the monitor is giving out, and it was proven many times that from far away, using a machine, you can reconstruct the image in the monitor. And this was done by the police many times in the 80s in this Tempest attack. So that was a type of side channel attack of magnetism, okay? The second one, it's acoustic. So that means using sound, and sound is incredibly powerful for this. We have many of these attacks. I'm going to show you, or not show you, but talk about one now, but it's when you're using any type of acoustic attacks that, you usually need a sensitive microphone, like the one in your phone, like the one in your computer, and this one captures sound produced by the components of the computer during cryptographic operations. Again, doesn't have to be cryptographic operations, but this is the most important thing to protect. If I have access to your private key, that's it. I can access all your emails and everything. So the moment your computer is creating those keys, if anybody can read it, that's it. They can access even your TLS connections. That's why it's usually the example. So the sound of electrical activity can produce clues about operations, and in this case, of the keys. So there is a project here that you can check that there are code that by listening the sound of your keys while you type, they can infer probabilistically what is that you are typing, because the keys are far away, because the way you press, you can do a small training with your fingers if you want, and then you can actually go and have this computer telling you which keys are you pressing only by the sound. A very similar attack was done 2 years ago, where they found that they can put this same program in your phone, and the people that is usually putting the phone in the same table that the computer is, the moment you type in your computer, by vibrations, they can register and sound the movements in the phone, and they can find out which keys you type in your computer. And this was very nice. They can actually steal your password because the table was vibrating and your phone was picking up with the sensors, okay? So that was all of these real attacks, including the more advanced ones, which is with lasers. If you put a laser in the computer, all the typings of the computer are actually picked up by the laser, and you can see the keys. There are many attacks of these ways. I'm not sure if you saw the documentary of Snowden, Citizen One. When he's in the bed and he's talking with the journalist, Snowden covered himself with a kind of, it's called a privacy blanket. It's just a blanket. So when you cover yourself like that, nobody can see, but also lasers don't go in, and you have a privacy to type in your own keyboard, okay? So imagine that he knew what he was talking about. So if Snowden is doing that, it's a real risk. So third one we are going to be talking about is power. Power is smart car power analysis, for example, where attacker monitors the power consumption of a smart car, right, like any smart car that you have with you, while it performs cryptographic operations. Imagine hardware wallets or things like that. And then there are variations in power usage that can provide information about the key used for encryption. And here also you have an example. So these ones are analyzing the consumption because CPUs are extremely optimized not to consume. So they are very, very, very low until they do an operation. And the people can see these operations, and then they can relate with the basic operations in the CPU from the assembly, and they know, oh, when you are doing AES, for example, you are doing, I don't know, 20 rounds of Xboxes, and that means XOR, and they know the operation, so they can actually find out your keys from there, okay? That's power. The next one, and the one we are actually going to try, is timing. Timing, it's a very, very crucial idea, and It's the idea that different data can cause a program or a system to run faster or slower. The moment you're doing operations in your computer, those operations, oh, my dragon wants to eat some chocolate. Yeah, it's fine. The moment you're doing operations, there is consumption of time, because some operations, in particular the cryptographic operations, take a lot of time. So if I can measure somehow the difference in time, for example, when a password is correct and when a password is incorrect, then I can check if a password is correct or incorrect only looking at the time. And this vulnerability, the time vulnerability, it's incredibly popular in hardware devices. Many devices that they have hardware, like keyboards to go into a door and things like that, they have slightly different differences in time when the password is correct and when the passwords are incorrect. Some of them are on purpose, some of them are not. For example, sometimes they add a delay at the end of the password so you don't brute force it. But also that's telling you that the password is incorrect. Some systems are giving you slight delays every time you press a key. So you can analyze this to find out which keys are correct. Was it clear, this one, the timing? Yes? No? Questions? Questions, V? No? OK. So let's try this one in your computers, OK? So get into your Dockers, please. And we are going to try the timing side channel attack. If Internet has questions, Internet, please tell us. Oof. Gangsters sweat a lot, I have to say. I will wait for you to get into your Dockers. I am here in my Dockers. So consider this piece of code that you have there. And I would like somebody to tell us in which part kind of a little bit insecure, in which part it's not well designed. I will give you some minutes. Also, Internet, we are going to wait for you. Tell us, Internet, what part of that code, or parts, are kind of not in the best way. And I have some chocolate, yes. Wait. Oh, there you go. Ooh, the hazmat radioactive person is going to bring something. Yeah, you need to run. Be careful. It's glowing. Be careful.
So first of all, we are comparing passwords, and we shouldn't do that. We should compare hashes. And even if we had, let's accept we are comparing passwords, we are having multiple stages where first we check the length, and so the attacker can deduce that if the delay is really short, the length is probably wrong, so he can reduce the number of tries to that. Then we are checking sequentially each password, so he can maybe guess how far it is on the list.
Did you get that, everybody? Yes? 3 things is checking passwords and should be checking hashes. And actually changing that into hashes is one of the ways of fixing it, because you just compare once and that's it, right? Second, it's the fact that there are 2 stages. In the first one is checking if the length is incorrect, is returning false. So the fastest of all the tests is telling you if the length is correct or not, and then it's checking letter by letter, okay? So there you go. Are you ready? 1, 2, 3, chocolate. There you go. So this that may sound to you silly or weird, unfortunately, is implemented in many devices. This is not our creation. I mean, it is, but it's real. So in this situation, we are going to have a server. You're going to be executing a server. And what is doing this server, okay, there's going to be a server that you're going to be trying to attack with this type of timing attacks. And the server is going to generate a random password, so it's different from all of you. And then it's going to open an API login bool so you can compare the length and check each character with a smile times lib. So what we are going to be doing is having a server with this password, and you can try to log in. If it's correct, it's going to say correct, and if not, not. And you are going to be doing the timing attack, OK? So let's jump into it. This server is in data timing demo. So the first thing that you are going to be doing is actually copying that into your home folder, please. So copy this into your home folder. Also the SEL, everybody, internet, everybody, just copy there, no problem, OK? So once you have it there, we are going to be creating a new tmax just for the server. So please create a tmax. I'm going to be doing it here, but also here. Then you need to install the dependencies. You can follow the instructions. I will give you time. You get into the folder. You install everything that you need, like the environment for Python. Ignore some errors there. Then you create a virtual environment. If you don't know what a Python virtual environment is, I suggest you go and read about it, because it's the preferred way to work in Python. So you create an environment. Then you activate the environment. So everything now is going to be relative to this local environment. OK? Then we install the dependencies. It's going to take some time. I'm going to give you the time. And you should end up with start server. Oh. I'm missing something here. Server start? Oh, sorry. I copied like a command. Start the server. We are going to be using UVcorn for this. Doesn't matter now, but it's kind of a asynchronous getaway for web applications, kind of API applications. So UVcorn is going to take the server app and open it in all your IPs in port 8000, OK? So when you press, oh, I think I have it already. Let me kill mine. I have many things going on here. Yeah, there you go. I want to take advantage to kill you. And now I'm going to execute it again. There you go, OK? So you should end up with the server running in your computer. I will give you some seconds. Internet. Remember, this is our server. This is the server that it's vulnerable on purpose. Yeah, that's it. It's fine. He feels hungry. Shh. Bad dragon. Bad dragon. OK, yes, question.
I have the same error. Can I ask how did you decide which processes?
Oh, because I knew here there was the UVcorn, this one. You can here read UV. So you should, I had a UVcorn, and so that's why the error was that the port was already taken. In my case, it was, hey, somebody's already opening that port. So check that you don't have any process opening port 8000. Anyway, you can choose another port, right? You can put port 8001, and it's fine. Just remember to use your special port later. Internet, you doing fine? Questions? No? Internet? All good? OK, so now you can detach from tmax. I was not in tmax? Oh, I thought it was in tmax. I was not? What did I do? What did I do? Huh. OK. Not sure why. OK. So tmax, I will do this. I think I didn't get in. There. OK, there you go. I have it in tmax now. So get out of your tmax. And now let's try the attack. OK? So for here, we have instructions that are going to run in the CTU students and instructions for the mock students, OK? So I'm going to be doing the CTU students. Please follow your own instructions here. So getting into the timing demo, I'm going to activate again the environment. Remember, I get out of the Tmax, so I need to activate the environment. OK? Then you need to install a couple more libraries. Remember, you are the client now. OK? And before attacking, what you're going to be doing, CTU students, is take your own IP address and please share it in the Matrix CTU students channel. OK? Please share your IP in the channel of Matrix. OK? So I'm going to go there. I'm going to say, hi, this is my IP. There you go. And you can see other people there. So what I'm going to be doing is I'm going to be picking some of you, like this one. So thank you very much, Joseph Lat. And this is going to be the server you're going to be using, because, of course, doesn't make sense that you're going to be attacking your own server. You know your password. So each of you started a server, and now you're going to be attacking some of your friends, OK? In a real scenario of a vulnerable server. Ready? If you're doing this on the internet, you just get into the CD timing demo, you activate it, and you're ready to run the Python, because you are going to be attacking your own server internet, OK? So right here in SEL. OK? I will give you some seconds. Ready? So once you have the IP of your friend, what you need to do is to execute the client and telling, hey, the server is in this HTTP endpoint. So you can copy this command, and now you need to copy your IP again. I was 042, OK? And once you have the IP of your friend, now the tool is going to start the attack. So I'm going to click Enter. It's going to be saying, starting the timing attack full. Remember that this is a remote server with a password that I don't know, but actually executing a vulnerable code. So I'm going to be leaving this, thank you, to the script. And now it's saying, hey, the length of the password is 5. Look at this. Password length distribution. So it's saying, well, the probability that the password is 4 character long is this number, 5, this number, 6, this number, 7, something, something. And then it's trying one by one each of the characters and say, hey, look, I'm trying the first character, index 0, and I found that the character is 8. And then I found that the character is 7. The third one is 2, and things like that, OK? Could you see that also? Do you see the attack working? Who can tell us for what you want, a Drago or Dragon? Oh, look, he's like a friend. Oh, he's a Dino. OK, yeah, a past relative. Or a Mando. I have this for you. So who can tell us how is the script working? Why? Where is the attack? What's going on here? What is this weird magic that you connect to a server? And actually, if you check, at the end it says, hey, the password is 87273, connecting with the password 87273, and success true. So this is the real password found. So?
Is it comparing the response time from the individual
Exactly. I'm not going to repeat because I cannot go there with the microphone. But yes, what you're saying is that there is sending of passwords, and when the length is actually not correct, it's rejecting you fast. So the timing of the answer is very, very fast. You try something, it's like, no, 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 right? And when you are correct, the time is larger or more, and then the same for each character. Once you have the length, you go character by character. Why this is probabilistic? Why this is not like one shot and then you know?
Because the server has some response time. It's not instant. In hardware instance, it would be much more reliable.
Exactly. There are timings in the server, and imagine this through the internet. Actually, the tools for the internet first measure the time to the internet, round trip, and then on top of that do the evaluation, right? And there are errors and packet loss. So if you are trying a character number 8 and it's slow, it can be because it's correct, or it can be because the packet got lost. So you need to try this many, many times. Here, I think the default is 50 per character to have a probability distributions of time, and then saying, well, the probability is actually slow or fast is this one or this one. So you are trying character by character, and then all of those should be like wrong, and then one should be right, okay? Everybody got it? Timing? Are you sure? Oh, I hope the dinosaur goes there correctly. Go, dinosaur! No, I overdid it, sorry. I'm sorry, he likes to fly. Well, they actually fly now. I mean, birds, not dinosaurs, but it's kind of the same. So, questions about this one? First side channel attack? Yes. Oh, can you?
When I attacked the same room like you, when it got posted immediately, so there was apparently a lot of attackers, and I got a success false code, which is, I assume, because there were multiple scripts banging against the door.
Exactly. Well done. You deserve a mando. There you go. Oh, perfect. Did you hear that? Because the server was loaded, the times were larger, not because of the script, but actually because of the CPU. So you have to be doing this in control situations. Usually the people is doing these attacks during the night or holidays, some place or moment that you know there is going to be less variation. So you measure the baseline, and then on top of that. Here, it can be very, very hard, okay? So if you have there false, it means that it was not able to find it. So you can do it again. If you actually want to try more, you can open the code and change 50 for 100 or 150, so you have more samples and then less probability of failure, okay? So this was for me, let me check, 37 seconds, okay? Now, we can try the same situation, but I'm gonna try the traditional way, which is brute forcing one by one each password. Like you did in SSH. Each password, you just send and you see how long it takes, okay? So this is the case of the brute forcing, and it's trying every password. And as you can see, this is going to take some time, because it can be 6 characters or 7 characters or 8 characters, and then, yeah, that's literally a long time, okay? So you may be lucky, of course. In average, you are going to be taking time like to reach half the list, but that's the difference between a traditional brute forcing and if you can find a timing attack in your servers, okay? So when you are hacking there, when you're doing pen testing, pay attention. A lot of developers make mistakes, and then you are going to have a timing attack, including things like, oh, the moment you log in, I'm going to check in, I don't know, where are you coming from, or the location of your computer, or whatever. Operations on the server side are going to make this harder. Okay, after doing this, and the same should be doing in SCL, yeah, this is exactly what the script was doing, right? Measuring the response time, statistically inferring the correct password length, the longer is the partial match, okay? And then to check if it works, you should have the true here, and if not, you can click more attempts, okay? So you can get out of the server after the attack. So if you go to your server again, I'm going to stop this because it's going to take a long time. I'm going to go into the server. Yeah, look at that. Oh, people is trying. OK, I will leave it working for you because you are trying, OK? Or not. Yeah. But remember to took it out. OK, everybody? Perfect. So now, let's see examples of real-world attacks that happen doing side-channel attacks. The first one is Rowhammer. Who can tell us what is Rowhammer about? This was a very famous one. Rowhammer. Rowhammer. I don't have my hammer here with me, but Rowhammer. Go, Max.
Rowhammer hammering the bit or the bytes that are on the next row in the physical memory, so that the bit gets flipped and corrupts something.
There you go. Did you get the answer from Max? No? Yes? Some of you are looking like, what? What? Somebody else? So what is happening, there you go, in mistakes were made both sides, so I'm sorry. So what's happening here is that you go to a memory position. I will scroll until the image. When you go to a memory position in RAM and you are storing a byte, you can choose the byte so it's all zeros or 0001 and 110 or whatever, right? So the moment you write and you put a 1, parentheses, depending on the technology of the type of memory, SD cards are different than hard disk, many things, and RAMs. So in some technologies, what happens is that the moment that you put a 1, electrically, you are putting some electricity there, you're storing, and that is producing induction, and is inducing an electromagnetic field. And if the memory is not good enough, that electromagnetic field can jump a little bit and influence the bit that is next to it. So not in one operation, but if you are doing this thousands of times, the continuity of the induction may produce a change in the next bit. Isn't this crazy for you? We are doing like, oh yeah, my security, firewalls, I don't know, zero trust, cloud-based Kubernetes something. And then we are saying that the way you store something in your memory can influence and change the bit next to it. That is crazy. And it happens. The attack is real, and it was much, much, much more real in the vulnerable hardware we had. It has a name. It's called Rowhammer. And if you do that, it may work. Still, some new technology. Remember what I was telling you, the devices. Many, many IoT devices are extremely cheap. And I mean it, people, extremely cheap. I'm not sure if you try some SD cards from far away. They work, but they're extremely cheap because the technology is very, very bad. And some of these technologies are still vulnerable to this problem, okay? So you can actually maybe try. So that is an example of a Rowhammer attack. And yes, of course, every environment that is shared, like cloud servers, VPNs, Dockers, computers with a lot of Dockers, you know what I mean? Some of these ones are explicitly vulnerable because you have many people there, and all of those are there in memory. Yes?
Didn't they have the same problem in NASA with this?
Radiation. It's a very interesting question. Yes. Oh, no, I stepped on the chocolate. So the question was, if NASA didn't have the same problem, with the radiation from space. It's not the same problem, but it's very similar. I'm sure you hear about this one, that when you go out of the atmosphere, there is no protection from radiation. So it's extremely easy for this radiation to go through the chips of the satellites and hit the memory and change the bits. This is very, very common. So common that if you send something to space, you need to shield it. Everything is shielded. Like your traditional hardware cannot go to space without a shield around. And this is actually true even on Earth. The probability of being hit by this on Earth is not zero. And there are, at least I remember, 2 registered cases verify that there was a mistake and a bug in a computer system because of radiation changes. Like some not neutrino, I don't know what, some ion of something, hit it and changed the bit, and it was a bit that was very meaningful, and then some error happened, and when they checked, it was because of this. So the probability of this happening is not 0. It's actually similar, let's say, okay? Okay, next hardware attack, it's meltdown. Sorry, did you realize that that was a side channel attack? Because it's the next row, right? It's like not the row you're actually writing, but the next one. So, meltdown attack. Who can tell us about meltdown? Meltdown, that was a very famous bug, people. It was something like, I don't know, 5 years ago, and the internet and the society was like, oh, we are gonna die. Apocalypse is here. I mean, they are saying that every month, but a lot of people were seriously concerned. Meltdown? Yes.
I think meltdown was a timing attack where the operation that was measured in time was prediction and misprediction of values across privilege boundaries.
Close, but it was not a timing attack. But close. Somebody else? Meltdown? So, meltdown. Is a side channel attack? Yes. And you have unprivileged access? Yes. You are not root, okay. And you can read privileged kernel memory, so you are not root, and you can read root things or other process, because you are abusing out of order and speculative execution. Who knows what is speculative execution? And you should know this one because it's a main feature of computer science hardware for the last 25 years. If you are studying hardware architectures, you should know about speculative execution. Now, your hardware architecture teacher is right now looking and saying, it was in the syllabus. No? Anybody? Oh, there you go. Oh, look at that. Are you ready? Ooh. Wave careful. Ooh. Okay, you are not doing that anymore. Go.
I think it's some instructions that repeat constantly, and these instructions can be maybe, I don't know, somehow cached, and we will just, I don't know, predict the result. And so this is something that relates with this instructions that repeat constantly, if I'm not mistaken. And
okay, that was hard to understand, but something about execution, and you were saying, I'm not sure.
Repeated instructions. So processor have some repeated instructions, and I just remember from one course that processor can predict the result.
There you go, predict the result. Yes, exactly. So what's going on is that CPUs and you people, are you ready for this? CPUs and people, oh, it was for him, sorry. So CPUs and people, they want to be faster and faster and faster in the CPUs. So how can a CPU be faster? One of the ways is that any moment that the CPU is running, it wants to be executing something, but you are not executing something the whole time. So when a program is loaded into the CPU for execution, the CPU is executing the most probable path in the program. So if your program is doing, if the password is correct, do this. If the password is incorrect, do that. If the user is logged in, do this. If all those if is one branch of execution or the other. And the CPU is predicting, that's the speculative part, speculating and saying, I think that the result is going to go into no. And then is loading those instructions and executing them, people, before you know the result. And then the result comes and says, oh no, the result was a yes. Oops, sorry. Let's discard all of this and execute the rest. So the CPU is speculating about the future, predicting, and that's why your CPUs are so much faster. This is one of the main characteristics of CPU. So what you are doing is you are triggering this speculative execution, so the moment that the CPU believes something is going to happen, the results of those operations impact something, in this case, the cache. So you have two branches, you are logging correctly or not. I don't know the password, so I'm always going to go into no. But if the CPU is predicting, it may load and execute the instruction of what happened when the login is true. And this goes into a cache. So the CPU says, oh, you want to read a piece of hard disk that is protected? No problem. I will pre-execute that. I will load that into the cache, and I will keep it into the cache. Usually, you should not access this information. Remember, this is privileged information. But what happened is that now you are doing a timing attack on the cache. That means, imagine that you are programming, and then you say, I'm going to create, or I'm going to read from the cache, and I'm going to read the first position of the cache. If there is nothing in the cache, then the timing is going to be very, very, very fast. Or, actually, I can try to write in the cache. And if that position of the cache is empty, I'm actually going to be writing, and it's going to be very, very slow. But if you are trying to write the letter A, and the letter A is already in the cache, you are going to be rejected very fast, because there is no need to write, because the A is already there. So you can go to the cache and say, can I write the letter A there? And if the letter A is already there, it's going to be, yeah, done. And if the letter A is not there, it's going to take time because you need to access the memory. So you can actually measure the time it takes to read the cache or to write the cache, and then you infer the content of the cache. Okay? It is a timing attack, not only, but yes, it is. So there is a timing attack reading the cache, but why the cache has important information? The cache has important information because the CPU speculated and loaded the cache for you. Was it clear? I have the feeling that not so much. So let's go forward a little bit, so we can see. Yeah, I will try to do this again. I'm an attacker. I execute the program or other programs many, many, many times to force the CPU to learn to load all these paths. So I am executing a program. Imagine local in your computer. You are not root. You're executing a program, and you're forcing the CPU to preload these executions. And you know that these executions of the branch that are privileged, you are gonna have that information in a cache. The cache can be as simple as a password store, a hash store, access to databases, or anything like that. And then you try to read or write from the cache, and measuring the time, you know if each byte is correct or not. So you are testing. Is the first letter in the cache A? No. Is the first letter in the cache B? Yes. Okay. Is the second letter in the cache C? Yes. You understand? So indirectly measuring the timing attack in the cache, because the CPU loaded, you can access this data. The latest POC that we have about this, by the way, if you didn't notice, this is a problem in the CPU. This is not a software issue. This was found in Intel AMD devices, millions of them all over the world. So the only way to actually fix this is usually changing the computer. Like in some cases, AMD release an update firmware from your CPU. I'm not sure when is the last time that you update the firmware of your CPU. It's a little bit hard to do. So it was a problem all over the world. You can log in to any computer in DigitalOcean, and you can use this to read memory that is private from any other instance of the VMs in that DigitalOcean. It was an issue, okay? So this next one I'm going to tell you is another attack that was after Meltdown. Once we have Meltdown and everyone was screaming and running, we have the Spectre attack. So Spectre attack is kind of a similar thing So also it's exploiting speculative execution and this brand prediction into executing the code path that normally would be inaccessible. The problem that now is not in the firmware of the CPU, but Spectre is in the software, okay? So a little bit easier to actually do. So in this example here, you can see that if you have an array that has a length and data, okay? And here you have user code. So you have your array A, your array B, and some sizing here, and you can read and write these ones, okay? Then you have some offset that you as an attacker control. It doesn't matter how, you control the offset. And then this is the part that is secret for you, because if the offset is less than some length, then you do that, but you don't know the length, okay? So you can actually input different offsets, and the moment the software hits this instruction, speculative execution may execute this code. And that means putting in the variable v the data that you cannot read, and then doing some operations and ons and ors and multiplications, and then getting the data back from this position. So this is actually what you can read and vulnerable access if Spectre is vulnerable, okay? Was it clear? Questions? No? Did I lost you? Are you still here? Internet? And no, we cannot try this because we cannot execute this in any hardware we have right now. But maybe you can try at home, okay? So it's a very, very similar way. The main mistraining the branch predictor. So actually you can execute with valid inputs until you learn that the condition is true, and then you do again the speculative execution with your malicious input. And then because you pre-train it by asking before, you are going to be loading this in the cache, okay? And yeah, the issue is that while the results are eventually discarded, right, it doesn't matter, all the side effects, like the cache, remain there. So the CPU discards instructions, you have your data. Okay? There are many ways of extracting the data. We put here the names of 2 techniques that you can search. What is called flash and reload. It's exactly what you think. You flash the cache, and then you reload it. Flash and reload, flash and reload. And the second is called prime and prove, where you are actually putting something, you are priming the cache, and then proving to see if it's still there or not. Okay? Questions about these 2 kind of hard-to-get hardware attacks? Do you get where was the side channel? All of these were side channel? Internet questions? I'm going to give time for the internet. OK, so if you have the idea of the timing attack, that's good. The AI view, people, AI view. So can AI help us here? Actually, it can. There is a very recent research about a side channel attack attacking LLM's queries that are encrypted. So the moment you connect to ChatGPT or Cloud or Gemini or whatever, you are connecting to a server, right? And then you are chatting. Very similar to the BSI Clippy. You are chatting, okay? Every time you chat, whatever you chat is converted into tokens. And those tokens answer to the server. So what happened is that those tokens are actually sent to the server and back to you. And if you are in streaming mode, remember when you are saying, hi, BSI, Clippy, and then it's answering you, hi, how are you? And then you see the tokens appear in time. So that's called streaming mode. Every new token arrives very fast. Each token goes in one packet in the network. So you can actually capture the packets, and that's what the researchers did. They capture the packets in the network, and then this packet is encrypted because it's TLS. I don't know, it's some HTTPS thing. It's completely encrypted, or quick, or something like that. But the length of the packet depends on the length of the token. So if the token is very small, the packet is going to be encrypted by, I don't know, 100 bytes. And if it's a little bit longer the token, it's going to be 105 bytes, 108 bytes, 102 bytes. So they are reading the length of the packets, and then from each length, they are trying to predict which token it was. Sounds crazy, but actually works. Because these researchers pre-train an LLM model, they train their own LLM to recognize those lengths and sizes following traditional, let's say, cryptographic techniques, like what is the most probable language? Maybe it's English, maybe Spanish, maybe something more. And then which are the tokens in Spanish and English? Like how long they are. And once they have one token, the probability of the next token, that's what LLMs actually do better. That's an LLM. So they're saying, well, if you say hi, the next one is going to be, how are you? You're not going to say hi and then medicine. Maybe yes, but the probability is super low. So they are based on probabilities to try to predict what are you typing and what is the LLM telling you. And according to the paper, it's actually good. More than 60, 70% of the time, they can find out what you are saying. That is a side channel attack. That is the length of the packets in the network telling you about the content. Okay? Questions? Internet questions?
I just want to add.
Cannot.
I just want to add that if you want to see this, there is a really nice demo in the document, so you can see how the attack works in real time, connecting to, I think, Microsoft Copilot in this case.
Yes, true story. If you want to see the video there is a beautiful demo of how to make this work with, and actually they have the code, and you can try by yourself, people, okay? So I'm going to stop here with the side channel attacks. And I'm being kicked out by the hazard people, and we are going to have the break, okay? So how long is the break? 5 minutes, says. 5. 5, okay. 10 minutes, and see you back here, internet, okay? So 3:37. No, sorry, 3:42, whatever. Yes, and there are stickers, people, remember. Oh, what happened? That was the dragon. Okay, so ready to go? Internet, come back. Internet, internet. I'm back to the family. Okay, so questions about the timing attacks, side channel attacks. We are not going to go back to this topic, okay? Except in the assignments and in the exam. The exam is only a side channel attack. That's a side channel exam. We need to do that one. So, after this way of getting into computers, we are going to move into what happens once you get into a computer. So, you already gain access because you are doing a Spectre, because you are doing a timing attack, because you are doing a side channel, because you exploit something. What do you do after that? And what we are going to be looking next is gaining persistence. So, who can tell us why do we need persistence? Why do we need persistence?
Well, because the way how you infiltrate the system the first time doesn't have to be open.
The way you infiltrate the system in the first time doesn't have to be open the next time. Completely true. What else? Another one? The way you get in can... Yes, getting in can be pretty annoying. Imagine the timing attack, right? You can be 3 hours doing, or like 3 days. So awesome, yes, you have a way to get in. You don't want to repeat this, right? What else?
The way we get in for the first time cannot be possible the second time.
Cannot be possible the second time. A lot of exploits are one-time exploits because they break something in the memory, for example, and then you cannot exploit again. So once, and that's it. And I am not dropping chocolates, but there you go. Hey, Max, also for you. Hey, you can start selling them. There you go. Ah, perfect. Oh, sorry. So, We have many reasons, but yes, the original vulnerability has been detected and solved, for example. The people is doing updates the whole time. There are changes in the configurations also, like configuration changing, even when you update the computer or because the people is changing by hand. Sometimes you need to hide the origin access. Sometimes you do have a vulnerability. But remember that the moment you use a vulnerability, you are kind of, how you say, like losing the vulnerability. If this is a new vulnerability, like a 0-day, remember 0 days, the vulnerabilities that are completely unknown, and the moment you use it is the first time you are using it, so it's a 0-day. Those you want to keep hidden. The moment you use it, then you are giving the vulnerability to somebody else. So sometimes you just want to use once because it's very expensive, okay? We already say this one, and yes, also because after a lot of things change, like rebooting the computer, you want to keep access, and those access may be lost. So how can you get persistence? And you can check the meter attack framework for all the cases of what is persistence and how, not how to do, but the options for persistence. There are like 25, maybe 40. The most important ones, account manipulation. So you can go and change passwords. So you get in, remember you already have access. One way to keep the access is maybe changing passwords of other users. You can go to users that are around, and you can change them passwords so you can log in as them later. If you have powers, you can create accounts. This is very common in web applications. Not so much in the console because you need to be root, but in web applications, sometimes you get into an application in the web and you gain access as maintainer, for example, and then you can create test accounts. So you can create 20 test accounts, and then you log in as those test accounts. You can actually do execution of your own scripts at the boot or the logon auto start, okay? We saw this before. Like when we say, well, the moment you are in the computer, you can go to etc initd in those scripts, and you can put your own code. That means that every time the computer restarts, your code is going to be executed. And then you can do whatever you want, okay? Another techniques that are actually very smart, like install browser extensions. This is super nice, because when you get access to a computer, usually it's not root, usually, and you can do a lot of things. And what you do is install in the browser of that victim some extension. And every time the victim is using a browser, you will have control of the browser and control of even execution in the terminal. You can do whatever from a browser extension. So you guarantee that every time that the browser is used, your code is going to be running. It's extremely hard to find out. You can also compromise binaries in the systems. You can go there as a user and put new binaries, hoping that somebody's going to execute them later. You can create or modify system processes. You can actually trigger execution by events, like every time somebody logins, that's an event. You can schedule a task or a job, like with cron and others. There are many, many. The point is that you are in, you are going to be kicked out in something like 1 hour. You need to maintain access here. How do you maintain the access? And those are the techniques. So let's do some example, okay? First example is going to be a remote shell with cron. So our goal is to automatically open a port in a victim's computer following a schedule so that the attacker can connect to it, okay? This is our goal. Questions now? Clear what we are going to be doing? So we will simulate that you access a remote computer with the user my victim. Then we are going to set up the port opening with cron job. And then we are going to connect to it from your attacker's Docker. This is what we are going to be doing. You're going to be doing here, and this is the victim. First step, once you have access, remember you already have access, is to open port, in this case now 1000 with netcat, and executing a shell. Then you are going to be using ncat to connect to this open port, and you connect to the open port and receive a shell back. Clear? No? Yes? Not so much? No questions? Internet questions? Okay, let's do it, people. So you have all your Dockers there. Dockers and CTU students and mock students both in the same situation. Go to your computer. Now I'm going to be doing in the SCL. I'm going to create a new tmax called victim that you can see there. Now, if you are online with a mock student, as a mock student, you, because you don't have friends around, I mean, you do have friends most probably, but not that you don't have friends. And here in your SCL, you don't have friends with you. You need to create your own NCAT, and then you are going to connect to it. And in the case of the SCL, remember that you start the class number 6. When you start class number 6 here, when you start class number 6, there is a new SSH Docker in your network that you are going to be using. So for the mock students, you need to connect to this new Docker in your network that is in 098. The password is admin. So now you are in your victim computer, okay? So the instructions, when say class container, they mean in this class container, victim, and not in your hacker lab, okay? This is a class container, internet. So, for CTU students and online, we do from here all together. First, we use the victim, my victim. Add user, my victim. Please remember the password. I'm going to put the password I remember. Very simple one. Room number, nothing, nothing, nothing. That's it. Remember the password of your user, my victim. The same you're going to be doing in your Dockers. Then you can check your IP address. And in the case of the, oh, here I don't have it because I don't need it. But in the case of the CTU students, you need to share this in your matrix again, okay? So you need somebody to play with you. So again, please go to matrix and say, this is my IP. Hi, this is my IP. Thanks. There you go. So put your IP in, in element. I'm going to take all of you. I'm going to wait. Okay? So, now that you put your IP for the CTU students in your Dockers, you need to be this user my victim. So if you pay attention, now I'm root. You don't want to be root. You want to be my victim. Why do I want to be the user my victim to execute the shell? This is going to be the victim, right? So all of you are going to play victim to somebody else. And all of you are going to be attacking somebody else. Why? The code that is going to execute the shell, allowing others to connect to you, you want to run with the user my victim and not with root. I don't want to give root access to other people in my network, okay? So, okay, I'm going to open a port with a shell, so anybody in the local network can attack me, and you can practice, but I don't want to give you root access. So I'm going to give you a specific UCID called my victim, okay? So now that you have my victim there, we are going to be editing the cron tab. Do you remember cron? I think it was second class or third class. Somebody does not remember cron? Internet? Cron is the daemon that executes programs in specific moments of time, that you can say something like execute this every Wednesday, or the March the 3rd, or the whole autumn, or whatever you want. So we are going to be using cron. Remember, this is you attacking the victim. This is you having access to a computer that is not yours. Okay, everybody? When you are playing the victim, you are playing in the victim, you are playing as an attacker having access to this computer. So, we are going to be editing the cron tab. That's cron tab -E. I'm going to be using Vim to edit it. This is the cron tab of my user, and I need to add this line to the cron tab. So please add that line to the cron tab. I'm going to give you some seconds. Then you have to save. And this line is executing every minute. That is the maximum execution time. Every day, every week, every day of the week, every hour, every minute. That is the start. The program NCAT. And NCAT is going to be listening in a port -L. The port is going to be 9000, opening a port. It's going to be restarted every time it finishes. So this is going to be kind of open the whole time. That's the -K. And every time a new connection comes to this NCAT that is listening, I'm going to execute a command. And the command is bin bash. Do you get it? And then, as we did so many times before, we are redirecting the standard output to dev null, which means I don't care what you are doing, just ignore it. We are redirecting the standard output to copy in the standard output, which means both the standard output and the standard error go to dev null. And we put the process in the background so runs alone. Okay, everybody? Questions? No? So now that we are opening the port, we have there the port 9000 giving a shell. And this is going to be run automatically by cron. So if you go to your victim, and 1 minute went by, and if you check, at some moment, it will actually try to open that port. Let's hope it works. I don't see it here. I'm a little bit concerned. OK, let's see what's going on. So then you get out of this Docker, sorry, Tmax. OK, so let's leave the Tmax. And now, because here in CTU, all of you are offering this victim port, let's attack people. So let's create a new attacker Tmax. I'm creating a new attacker Tmax. And then you can do NCAT directly to the IP of your victim port 9000. OK? So in here, because I'm using the SCL, I'm going to be attacking the IP 098. It's not opening for me, so I'm going to check again because the port is not open. I will first try in CTU, and I will pick one of your IPs, people, like this one. There you go. And how to know if this is working now you are connected? Well, I will execute a program, and then you see I have shell access. OK? Do you see that? You should be able to connect to your victims, port 9000, and the moment you do any command, you should be able to run that command. Please be sure that you see this working. While you are doing this here in CVUT, I'm going to check my issue with SCL. Let me see what happened here. Admin is the password. Cron tab. Oh, I think I know. Oh, cron tab is empty. Oh, yeah, because it was my my victim. So my victim. It was not my victim. Weird. Huh, interesting. OK, I used my victim. I don't know what happened there. I just created before. OK, and now I'm my victim. OK, and now I'm going to be doing cron tab again. Cron tab. Yes. Huh, weird. Like if it was restarted or something. OK. And if I do cron tab -L, it's there. and I'm going to check my date, and I'm going to check my processes. I will check again, where is my NCAT, user bin NCAT, maybe that was an issue. Did it work for the internet people, SCL? Please tell us if there was an issue or not. Somebody, yes, internet work? Okay, I don't know why it didn't work for me. So, was it clear what happened, people? Questions? Somebody lost? Remote shell, very common technique. You need to do this 1,000 times. You get into the computer. How you get access to maintain the access? Well, you just open a port with a shell, and that's it. The moment you connect, you have a shell. Why is not asking me for user and password? Who can tell me? For something. Who can tell me why, when you're doing this command, it's not asking me for user and password? Why I can execution of a shell without user and password? Very nice. There you go. So you have a chocolate, a Mando, or a phone holder. Chocolate. There you go. Hey! Oh, I'm sorry. I can give you another one. So he was saying that we are attaching the shell to the NCAT process, and the asking for authentication or user or password, which is usually through the PAM daemon, it's an operating system process that it's ready there checking your user and password. SSH is using that. So you need a program that wants to check your user and password to check it. NCAT is my program. I don't care user and password. I just connect the connection and give you the shell, right? I don't want to check it, so there is nothing there to check. Was it clear? This is not using the traditional mechanisms for user and password in the system. Okay, so let's move to the next one now. Now that you attack the victim and you have everything there, there are some cons and pros. Who can tell us the cons and pros? Which are the good things and the bad things of this technique? Good and bad. Come on, people, so we can move to the reverse one. What is good and bad about this approach? We have many. Come on, I know you can do it. What is very nice about this approach? What is very bad about this approach? We just went to your victim, open a port, give a shell, and you connect from your computer. Sorry. Yes, go. Oh, yeah. Oh, sorry. Yeah, it's fine, go. So it's saying that the victim can see what's happening in the computer, so it's better to do the reverse. It's true that the victim can see what's happening, but also may be able to see the reverse one. So yes, true, but it's not the difference right now. Anyone can connect. That's true. You're opening the port, but it's not for you. Anyone here, and if you're doing this on the internet, anyone on the internet that finds the port executes commands. And that's very bad. Well, probably for you and for me. For others, it's going to be awesome. And this happens. Sometimes you find the port on the internet, and you connect, boop, and it's already there, some shell, right? So it does happen. Something more? Oh, I'm so sorry. I'm losing the cigarette is killing me. Okay, so I am gonna uncover the hidden text. But yes, the firewall, for example, may not allow your connection from the internet to the internal server. So you went to a victim and you open a port. That victim can be inside the corporation. When you connect from the internet there, you're not going to reach that port. There are going to be firewalls and routers, so this is going to be very hard, right? And also, connections getting two computers in an organization are very suspicious. This is very easy to detect. So you don't want to be going to the organization and actually getting there. As a pro, you have that as an attacker, you know the IP address because that's the victim. You know the port, so that's awesome. You can connect from any place on the internet, and that's fine. And of course, like you said, any attacker can connect, okay? So let's do the second type, the reverse one. So how is the reverse with cron? Well, what's going on in here is that we are going to automatically make a victim computers connect to open port in the attacker computer. So this is what's going on. First, we open the port in the attacker computer. Second, we use NCAT with a shell to connect to us. So now it's not us connecting there, it's the computer victim connecting to us, okay? So let's try this one. CTU students, also remember to put your IP in matrix so the people can find you. Preparation as a victim to send the shell. You need to actually create the Docker, the tmax victim if you don't have it. So I'm gonna get out of here. I'm gonna check that I don't have my victim one. There you go. I create my victim tmax. I'm gonna edit the cron tab of the victim. I need to be the victim here again. So the user, my victim. Okay, I already have it, so my victim, there you go. I'm gonna edit the cron tab of user my victim. Okay, remember here to be your victim. So I wanna do my victim, so you don't forget that one. Okay, and I'm gonna be copying this command that of course is incomplete, because it says my friend's IP. So here, you need to know the IP where you want to send the shell. So that's why you have friends in matrix. I'm going to copy this one. And now, remember, I'm going to be giving a shell in my computer to this computer in particular, okay? So maybe somebody is not giving to you the shell. Maybe it is. You need to be lucky. Okay, so here I'm going to be doing to 014. I don't know who is 014. There you go. It's installed. And if you are doing this in online for the mock students, it's exactly the same. You create your victim one, and then you do the cron tab. Remember that this is in the class container internet. Class container, okay? That means in here, class container, my victim, okay? You need to do it in here. And then once this is running, if you are on the internet, you need to do it in there. But once this is running, all the victims are running. Now let's gonna play the role of the attacker. So as an attacker, you get out of this cron tab. You create a new tmax for the attacker. Okay? All of you are already a victim, giving a shell to somebody. That's fine. Now we need to be the somebody. So now you need to open a port and just wait for your victim to connect to you. The attacker is opening the port and nothing else. You just stay there, waiting, because you know that somebody, your victim, is going to have a cron tab job that every minute is going to open the NCAT and try to connect to you. You are playing the role of the server here. Is it clear, internet? You are playing the role of the internet. So if I was lucky, and if a minute went by, and if somebody chose me as the attacker, I will do a command. See, here I know nobody connected to me yet because I did a command and nothing happened. Okay? So I will wait to see who can connect to me. And tell me if some of you connect to you already. Okay? I'm going to be doing this in the SEC lab. So I can have it also there. There you go. In SEC Lab, you are connecting to your Hacker Lab, okay? So that's going to be the Hacker Lab. And now I'm going to connect out. Oh, I think I should have stay there. Oh, no, it doesn't matter. Okay. And now, in your Hacker Lab, you have to just connect and wait. Okay? So, anybody has already some connection to them? Anybody put my IP to give me a shell in your computer? Anybody receive a shell? No? Yes? Did you give your shell to somebody using cron tab? All of you? If you are not executing the cron tab, your friends cannot see the result, okay? So put your cron tab, my victim. Actually, you can put all the IPs you want, one after the other. I don't have nothing. What I will do is I put some VVs, so I have an idea of if somebody's connecting or not. Yes?
Can multiple people connect to my netcat at the same time?
They can.
The question was if multiple people can connect to the netcat at the same time.
Thank you. Yes, they can. Well, it depends how you set up.
I wanted to see who connected to me.
Yes.
Yes.
Yes, because that's the -K. The -K, called the broker mode, it's waiting for a new client, and the moment somebody connects, it's spawning a new NCAT, kind of Apache. So you can have multiple clients. Oh, there, I have 2 connections. Oh, look at that. Oh, my friends.
Sebastian?
Yes.
In the meantime, could you please reiterate on the last exercise that we did? There are some people that feel a bit lost. So explain what's the benefit of that and how is it different from
this last one.
Yeah.
Perfect. So we can do this one again. So this one, that is a reverse shell, we are going to be always having access to a victim, force the victim to connect to us attackers with NCAT, and give us a shell. And we, as attackers, open the port waiting for the shell. That's why it's called a reverse shell, because it's from the victim to me. Okay, everybody? Questions, internet, was it clear? Here, everybody? Sure, you got this one. No problems. There are many benefits of this. Like Max was saying, a lot of people can connect to you. So now I had 2 people before. Now I have 2 new people. I have 4 shells connecting back to me, which means every time I do a command, I'm sending to 4 computers at once. Look at that. That's so nice. I have like a botnet right there. I'm controlling 4 computers simultaneously. And this is what we are going to be looking later, actually the start of botnets. We are going to end up in a couple of classes creating a botnet. This is your first steps toward automation, okay? Was it clear for everybody what's happening? Somebody's lost, who is connecting to whom, why? We can repeat it, people.
Yes.
I have another one. Okay, so.
Maybe you can explain. Sorry,
No, go. Maybe I can explain.
You can explain if you need to stop the things from the previous one.
Yes.
How do you listen to the incoming commands?
Yes. So you do not need to stop the previous one, because the previous one, you were opening a port 9000 in the victim and you were connecting. Now, you're opening the port 9000 in your computer and the victim is connecting to you. Both can work simultaneously, no problems, okay? And the way I can see if somebody's connecting to me or not is because, in my execution, I actually use --b. Okay, I did this. I'm going to put it here. In my execution of NCAT, I did -vv, which is verbose. So I can see when the people is connecting, okay? So, pros and cons, a lot of pros and cons. First, now we can jump firewalls because it's the victim connecting to me, exactly like malware is doing. We can go through any filtering in the firewalls. The malware, or in this case, my NCAT, will connect to me, and then I will receive all of them simultaneously. It's a much better setup. Of course, the problem is that my IP address is going to be in the victim, and that's bad. So you need to deal with that one, okay? So, extra ideas. Of course, you can have persistence following this payload all the things technique that you can go and read. The reverse SSH is very similar to the reverse NCAT, but using SSH. I suggest you read that one. You can actually add encryption to NCAT, so which is very, very easy. Just put the dash SSL. You can put other ports, like 443, so it's not easy to detect you. So if you do this technique with port 443 and TLS, it's going to be extremely hard to realize that you are doing this. The people will be looking at the traffic, and it's like very hard, okay? And then we will see the automation later. So other things that you can do here, I don't know what happened to the document. Other things that you can do here, it's using NCAT for many things, and I like the property of a chatting mechanism. So what I'm going to be doing is executing NCAT, only me, so you can see here in the screen, and I'm going to say, hey, NCAT, do broker mode and mode chat. That is a way to, when two clients connect to my NCAT, I will connect them between themselves, okay? And whatever they send, I'm going to send to each other. That's called the chat and broker mode. So I'm going to be executing this in my computer. I'm going to create a tmax called chat. Oh, I am already in one. Yeah. So look at this. I'm going to just execute my NCAT import 9999. OK? I'm going to leave it there. And now, all of you here in CTU, you can connect to my computer, and you can actually chat there. Oh, see, you have people there. So this is a very easy way to actually connect others, and you can share information. Oh, look at that. Oh, happy Halloween, people. So NCAT is, please try and connect there. NCAT is actually a very versatile tool and one of the most used tools for this type of scans. Yeah? And we have so many connectors and users. Oh, hi. So many people. Questions so much so far? Yes. Yes. No way, because the NCAT is putting a user, and that's it. There is no real like chatting login in the sense of a normal way. It's just, oh, you are using 14, and that's it, right? Oh, look at that. More questions? Somebody's lost what's going on? Internet? I'm sorry, Internet, you cannot connect to this one because it's internal, but you can do this at home with your friends too. It's kind of the poor man's chat, let's say, the poor man's WhatsApp in a way, right? There you go. Oh, see, we have images too. Images are so nice. Okay, so let's move forward. Next topic is going to be privilege escalation. What does it mean, privilege escalation? Who can tell us? Privilege escalation. What is to escalate privileges in a computer? You already get in. You already have your persistence. You can log in whenever you want. Next step, to escalate privileges. Huh? Until? I cannot do anything until I become root. Do you agree with the statement of you can do anything until you are root? You can do stuff. Now he's like, oh, no, I didn't want to say that. Yes, yes. You can do some stuff. So privilege escalation is the way or the idea of gaining more power, whatever that means, that you didn't have before due to authorization problems. It does not mean another authentication. You don't want to authenticate. Actually, you don't have the password. What you want is the power. So you want to have or another user or another database access or another permission that allows you to do things that you couldn't do before, okay? So, do you need to be root? Well, actually, not so much. Most of the time, you don't want to be root, right? The idea is that any attack that abuses any resources, like CPU and memory and you don't need to be root. Like in any attack that you do like a crypto mining or like you do, I don't know, yeah, Bitcoin or any other one, you don't need to be root. You just go, execute, and use it. Even if you want to abuse the GPU, that's it. No need to be root in there, including JavaScript in web pages, right? If you want to install a server and you don't want to be in a privileged port, like it's like less than 1024, you don't need to be root, like we did just now with NCAT. So that far, no need to be root. IoT, the same idea. Just execute and use the bandwidth. Execute something in the memory of the camera and then go to the internet and scan. No problem there. What about advanced persistent threats? These like state-sponsor, you know, like attackers of the war. Well, also it's better if you're not root, because when you're root, many more things apply, and you're going to be monitored much more. So actually, being root is not what you want, because everyone is watching the logins of root, okay? You can still do lateral movement, which means jump from one computer to the other. You can still access the local databases ports, no problem without being root. You can have web shells, no problem without being root. So there are not many reasons why to be root. Among the reasons are installation of global programs, if you need something that is globally in the computer, modification of the kernel, including modules, you need to be root, sniffing packet, sometimes you need to be root, sometimes not, use of restricted ports, deleting your traces, adding users, and importantly in Windows, you need to be administrator to be able to read the memory, because in the memory you have the hashes and other passwords and credentials. So in Windows, you want to be root because you can read the memory and download the LDAP admin credentials, for example, okay? So, some ways to actually escalate privileges. Checking, the full list is here, so you can go and do this checking of all the techniques in the privilege escalation checklist, but as always, you need to earn as much information as you can about the system. You need to know the system you're working on. If not, it's going to be extremely hard. You can brute force the user's passwords of the admin. You can social engineer in them. You can do exploits in the kernel. Extremely hard, but they are there. You have an example in OpenWL here. You can do local exploiting programs of misconfigurations or others. The one we are going to be using now is SUID binaries. So, what is a SUID binary? A SUID or SUID binary is a file in your system that has special bits set, special permissions, okay? And they are very necessary. They are not a vulnerability. So consider this example. You are in the system, and all your passwords are stored in its shadow. Right? You already saw this. And if, as a normal user, you go to its shadow, you cannot read this, right? But if you cannot read or write the file, how come that you can change your own password? Who can tell me? You are here. I'm going to be the user, my victim. If I do a cut of its shadow, I cannot see it. But I can actually change my own password. How come, if I cannot read or write that file, I can actually change my password? I can preemptively drop candies to stimulate the answer. The privileges of... It's about the privileges of the user of the group. It's not the privileges of the user of the group. It's the go.
Is there some authentication service or some?
No authentication service. Is there some authentication service? No. Similar to what he said, if the user has privileges to check, no privileges for the user special ones. Very well. The binary passwd, this binary, let me see if I can stop it. This binary actually has some special permissions. And even if you list, the system shows in red because it's very dangerous. The magic is that passwd, exactly, is that S here. So that passwd, if you remember before, looking at the permissions, you were saying RWX for the rest of the world, RWX for the group, RWX for the user. But there are 3 more special permissions that are called the set user ID bit, the set group ID bit, and the sticky bit. All these 3 that you can put following this octal notation appear in the position of the X of the user, the X of the group, or the X of the rest of the people. And the meaning is this one, okay? Follow me here. A program that has the set UID bit on, the moment you execute, is going to create a process. That process is created with the permissions of the owner of the program file. So what's important here is who owns the file. If this file is owned by root and has the set user ID bit on, the moment I execute that file, even though I'm not root, the moment I execute this file, the permissions of the process are going to be roots. Was it clear? Okay, let's try them. So we have many of these programs around. You need these ones, so these are official ones. As you can imagine, they are very, very dangerous, so you need to track them, okay? So how do you find which ones are in your system? Well, this way. Find from the beginning of your computer with the permissions where the user are S, that means the set user ID for the user, the types are file, and when you find them, execute ls-la and redirect everything to dev null, the standard error, and just print the rest. So this command is going to show in your computer all the binaries that actually have the set user ID on. Please check them. Internet? Questions? I can do it here too. There you go. Okay? That's the way you find them. So, how do you set? Yes, go.
Maybe why do we want to have the files with this permission?
Well, you need
What was the question was,
Thank you.
why do we need some files to have these permissions or
Yes.
these bits to set to true?
Thank you very much. So the reason why is because sometimes you need, like in the passwd, some permission that the user does not have but needs to do. Like passwd, or in this case, for example, mounting a file system or unmounting the file system. Actually, the idea of the sudo changing users, how can you execute something like another user if you're not that user, right? Or like creating groups or others. So there are some parts, operations that you need more permissions that you have, but you don't want to give full permissions to this user, right? As you can imagine, the code, the literally C code of those programs is extremely, extremely vulnerable. The people coding those binaries are extremely sure they don't have any vulnerabilities. The moment you have a vulnerability in these programs, we are done, right? Anybody can be root or something. So once you find them, let's actually use them, okay? So the way to do it with chmod, and then you can do +s, or if you like the octal notation, you put the 4 in the 4th position, and that's it. That file is just gaining the set user ID permissions, okay? So let's try. Ready? Internet, are you ready? First, if you are on the internet, mock students, you don't have your compiling utilities installed, so you can download directly the compile binary from here in your SCL, okay? So this is if you're here on the internet, you can just download here. For CTU students, we are gonna compile it, okay? So create a file called tmp suid example.c. Please create that file, and in that file put this content that you see here. Oh, come on. I will do this as root, and then we are gonna in C create in the function main, set the SUID to root, and then execute a shell. So what we are gonna be doing here is you momentarily gain root access. How can you give yourself root access again in the future? Well, this is a way to do that. As root, we are gonna create a binary that is gonna be giving shell, and we are gonna be putting the set user ID permissions. So you create this file, please, save the file, then you can compile it with GCC. Forget the errors. Internet, remember you already have the binary, so don't worry. Oh, I'm doing this in whatever, it doesn't matter. Okay? And once you have this compile, it's gonna be output in tmp suid example. So this is your binary, okay? Compilation work? Yes, yes, no, no, maybe, yes. And once the compilation work, we are gonna first be sure that has root as the owner and root as the group. Then we are gonna be giving execution permissions. This is last class, 2 classes ago. So you know this one, +x. And now, the new one, we are gonna be doing chmod +s to give set user ID permissions to this binary. Okay? Everybody? Be sure you do that. Internet, you can just do it from here, okay? Because you already have it. SUID, SUID, I don't have it. Oh, dash, sorry, internet. So internet for you is chmod, not underscore, but dash, okay, internet? Dash for internet. Or I can put it like this. Okay, do you have it? Oh, perfect, thank you. So now that you have it, let's change into a non-root user. Now you are simulating that you are coming back in a month. So you are here. Now you are not root. If you do ID, you are not root. But because you left this backdoor in the system, the moment you execute that tmp suid example, look at this. Now you are root. Was it clear what happened? Somebody lost? Questions? No? Internet questions? You sure? Okay, that is a backdoor, people, and a beautiful binary to leave there. And by the way, that's not malicious, so nobody's detecting it, not virus total, not anybody. It's just very weird. Let's jump into the next example. Instead of using set user ID binaries, we are going to be using get the fuck beans. Get the fuck beans. So get the fuck out beans are special type of beans where the community found that they are official, but we can abuse them to get out into a shell from programs that have nothing to do with shells. So we are taking a program and we are forcing it to do something that was not designed to do, kind of fish. Maybe yes, it was designed. It's a little bit weird. Many of these binaries. And you can find the get the for beans here in this list. So usually there are kind of restricted shells that limit the users in the actions you can do, right? For example, rbash is an example where you cannot do certain things. You have a lot of limitations. This is very common in a lot of things, in a lot of systems. So let's do an example of using the base 64 binary to break out and actually execute commands. And you say, what? Base 64? What is the relationship between base 64 and commands, right? Okay, so let's do it. First one, in your containers, we are going to create a secret file in TMP as root, and we are going to put inside hello BSI class, okay? So I'm going to get out of all of this in your Dockers, and I'm going to create a file, TMP secret file, okay? The same for you, internet. You create it in your SCL. Now, we are going to give as permissions 400, means the owner can read, the rest can do nothing. Okay, everybody? And now, we are going to be using the install, which is a standard Unix command, to copy files and set ownership permissions. So we are going to be copying our base 64 binary, wherever that is, so which is telling me where is base 64, and this we are copying into TMP base 64 bad, and the modifications in install we are going to be using are going to be to put the set user ID and the execution in the copy. So install is a program that is going to take the original base 64, change the owner and the set user ID, and put it here. We just put it, it's a little bit fancy. It's like you can copy it by hand, right? It's fine. But this is kind of a one-liner fancy thing, okay? Once you do that, now you have a copy of your base 62 binary that actually is set user ID, okay? Now, change into the user victim, please. And as a user victim, you can actually try to see the secret file, and you cannot see the secret file because you are not root. But if you use the new base 64 that has the set user ID, and you open Nasdarabi, the file, you can actually encode it, and then you can decode it. And when you encode it and decode it with this file, you now can see the content, even though you couldn't before. Was it clear? What happened? It was a little bit convoluted, but we took the base 64 binary that is used for base 64 encoding and decoding. We gave the set user ID permissions, and now we use that one to access a file, encode it, and just give it to us, and we decode it. Even if we don't have permissions, base 64 did have permissions. Was it clear? This is going to be maybe in the assignments, maybe in the bonus, maybe in the exams. I'm not sure. Maybe in all of them. Maybe none. Questions? No?
Can you
Huh?
1 minute?
Sorry?
Can you give 1 minute?
Yes, I can give 1 minute to everybody. Everybody. Yes, question about the binary.
Back with the cube.
Yes.
It's the so the way how it works is the same binary which is used by root, and that's why you have the access, or
It's not used by root. How does it work, this binary? I'm not root, I'm still my victim. So I, not being root, execute this file, and that file has special permissions, that is the set user ID bit. That means, as my victim, I press enter, the operating system takes this file, opens, loads into memory as a new process, but the moment it's loading this as a new process, it's changing the permission of the process to be the owner. The owner is root. Now that code runs in memory as if root press enter. I cannot control the content of base64. I cannot even read it. I cannot, as a non-root, I cannot modify. But the community knows a lot of these programs that are supposed to check the time, send an email, but we can kind of use them to read files, to execute commands, and other things that are weird. That's why they were called the get the fuck out beans. It's like, yeah, these binaries were supposed to do something else, and we kind of using corner cases to do things that usually you don't want the people to do, right?
Okay.
Yeah.
But it seems to me that almost nothing should have that flag. Like, this sounds really dangerous for a program to have that any user can execute. So maybe only the processor should have it, but like, it shouldn't be given to.
Yeah, yeah. So the comment is, these are dangerous, and sounds like nothing should have these permissions. I agree with you. That's why you, when you are defending your computer, you need to find which ones are installed and check them, that they are not modified, that there are no new, and stuff like that. But you need them. Remember, from changing the password to other things, you need them. I agree with you that this is 9060 technology. We have much better ways of doing this. Remember all the things we did with the permissions before, like 2 classes ago. Like, we can do this better, but they still exist. And as a defender, you need to check in case an attacker adds some of those. Even if you don't like them, it's still possible to do it, right? So even if you don't install, somebody else may install them, okay? Okay, let's jump into our sudo vulnerability. Sudo had an incredibly bad vulnerability in 2019. Oh, break. Okay. Yes, sudo is broken. Yes. Now, so let's take a break, people. Internet, 10 minutes from now. See you back at 4:53 Prague time. Okay? Go get a sandwich, get that cheese fondue, or whatever you're having, and back in 10 minutes. Or bathroom, or cheese fondue in the bathroom. We are ready, right? Okay, let's continue, people. Internet, come back. Come back, internet. Come back to us. So, the issue is, we know that these commands and exercises can be confusing. I'm not sure it happened to you, but knowing which user, root, not root, Docker, no Docker, Tmax, double Docker, double SCL, it's complex. We will try to find a way to show this in a better way, but it's kind of hard. So the best way we are doing right now is, remember, by using the labels of where you should be when you're executing this. So allegedly, you can follow top to bottom. And if you see that, you execute this in the Hacker Lab. And then this is only for CTU students, Docker container, and the rest. If you follow that, we hope that everything works correctly. And yes, from time to time, you have to jump some things. I know it's not the best way, so we will do our best, OK? If it's confusing, just stop us. So the sudo vulnerability. Remember, we're trying to find ways to actually get and execute privileges elevated that we didn't have. So the sudo vulnerability is a vulnerability for 2019, which was actually very important because if you remember, sudo allows you to execute commands as another user. So this is the type of program that you want a lot of security. And there was a vulnerability. It was actually very important, and it was an issue in every installation of sudo until the moment. So what's happened is that it's a policy bypass vulnerability. And in here, what happened is that a user who had a specific type of sudo permission, for example, you were allowed to run a certain binary, and anybody can do it except root, anybody but root, because sometimes you want to protect, and nobody can run this as root, which makes sense. In this vulnerability, you can actually trick sudo into running this command as root, even though it was forbidden by the policy, OK? So if you have a system with this vulnerability, then you can try to execute commands as root. So this works because sudo accepts a numeric user ID parameter. So you are saying, I want to run this as the user 22, as the user 19, and others. The problem was that you could also request -1 as the user ID. And the vulnerability was there that when you say -1, mistakes were done, and actually 0 was given to you. And 0 is the user ID of root. So that was a vulnerability, OK? So let's make it happen, people. If you are on the internet, you need to install these essentials, not you here in CTU, OK? So if you are in the internet, you need to do that. Now, what you need to do here in CTU is that you need to remove the previous sudo, because this is the one that is not vulnerable. So in CTU, as root, you need to actually try to remove the sudo. I already did it. That's why that's the error, OK? So please remove sudo. On the internet, you don't need to do that. Then I'm going to move the sudoers file to a backup. I'm going to move the sudoers directory to a backup, so you actually don't lose your previous ones, OK? Because remember, after the class, you need to go back and actually make it secure again. So how can we exploit this vulnerability? The first thing everybody needs to do is to get the vulnerable sudo, because, of course, after the vulnerability, sudo was updated. So the current sudo is not vulnerable. So we need to bring a vulnerable sudo to the system to simulate. So with wget, you can actually get this sudo. After you got that sudo, you can get into the folder where you open it, tmp sudo 1827. Once you get into this folder, everybody, you need to configure, because you need to build the sudo. It's going to take some time, the configuration. There you go. Once the sudo is configured, you need to compile it and install. Make and make install. This is the way that you can actually compile and install the package. After this, all of you should have in your Dockers and in your SCL a vulnerable sudo binary. OK? I will give you some seconds to finish. Also, I will try to move less between my screens so I'm not confusing you. Ready? Now that you have that, we need to actually make the configuration policy, and for that, we are going to be using vsudo. Vsudo is kind of a V for sudo, and it's the preferred way of editing the file, because editing this file actually is having a problem if many users are editing at the same time. So when you're using vsudo, you are sure that only one user is editing the sudo, and that's you. So what you need to do is insert this line in the vsudo, making the my victim user allowing to run user bin vim as root, but not to the root user. My victim cannot the root user. So you just go to any part of the file and you put that configuration. Then you save and you get out. I'm going to give you some time. So internet, you're sure you can do this. I'm adding a policy check in sudo. So let's try. Now that we have the policy in place, I will change my user into the victim user. From now on, again, you are my victim. Okay? And as my victim, I'm going to request, hey, I want to execute vim with sudo. When you do this, it should ask for your password. It's going to tell you, OK, you want to run vim using sudo? No problem. And you need to remember the password of your user. I remember my user. But when I try to do that, it's telling me, hey, look, you ask for the execution of vim, but you are not authorized. Remember the configuration we put in here. You are not authorized. You, remember the configuration, user my victim cannot run this as root. You, user my victim, cannot run this program as root, not root. OK? Everybody clear? This is the policy working. You ask to execute vim as root, and the policy says you cannot execute as root. OK? Now, let's exploit it, people. To exploit it, what we do is sudo, and then we ask, oh, I want to run this as the user ID -1. So when you do that, and you ask -1, and you put your password, ta-da! We have V. So be sure that you see the vulnerability working. Internet? Did it work for you? Questions if not? Errors? Bugs? Now, as a side question, you can ask to run with the user ID -1, but also with this user ID. Can anybody tell me why this user ID works? That is, I don't know, 7 billion, 4 billion, something, something. Why running with the user ID -1 works, and running with that user ID 4 billion also work? Huh? 32-bit integers, that's a little bit more to that. You can improve it. He says 32-bit integers, they're the same number. Sign -1. OK, so these numbers, the signed integer and the unsigned integer, are the same bits, different decimals, because one is unsigned and the other one is signed. OK? So there you go. Another chocolate for you. Oh, sorry. Did you move to the other seat? I think you were here before. Okay, so now let's go further, because having Vim as root is amazing, but what can you do? Like edit a file, it's a little bit weird. So what we are going to be doing is executing Vim as root, but we are going to be using a special parameter in V that is the command, and the command is shell. So when we do that, now we are root, and we gain root access to type commands exploiting a local vulnerability. Please try, internet try, to make sure it works. It should work for you. Remember, you need to elevate privileges with this. Clear? And then you need to exit VIP2. OK, so next, I'm going to be showing the password of the class. So it's 1, 2, 3. That's it. The password of the class is crash leave, crash leave. OK? That's the password of the class for online people. And bye-bye. OK, now that you already are doing all this by hand, we want to show you how to kind of automate it, because of course you can automate it. And we are going to be using a very simple tool called the PSNG, before called the limpas. And this tool actually can be used automatically to find all the problems and vulnerabilities to exploit in your local computer. So you need to do a non-root user. I'm going to be putting my victim here. It's the same. You can use my victim. I don't care. My victim, because you already have it, right? So if you are the user my victim, just have some user that is not root. I'm going to wait for you, internet. I'm going to be doing this in SEL, so you can also see here. OK? You should be doing this in the internet. And we are going to be downloading the limpas script directly from the internet. And then we are going to be executing it. And then we are going to be storing the output in a log file with the command that is T. T is simultaneously storing in a file and the standard output. And then we are going to be piping to less so we can stop this and read. OK? So when you run this tool from the internet, there you go. You will see something like this with kind of a thingy going on. This tool, you can scroll down, is downloading a script from the internet, and then one by one, it's going to check all the information in your computer. It's going to check, for example, telling you that you have some programs that are available for network discovery, even finding that Nmap is there, information about the system, the sudo version, the date and time, the mounted file system, and slowly it's going to check all the things we saw, all the previous classes, to tell you how can you attack this computer. It's going to tell you the SUID beans. It's going to tell you any problem with the permissions. It's going to tell you even if you're in a container or not. It's going to find that you're in a Docker and many others. Okay? So we recommend you go and check this tool and see the output so you can actually analyze the security of a computer. Okay? Did it work for you? They have something there? We are not going to go through the log because it's like thousands of lines, OK? So you can go and check a lot of the things we already saw in the class. It's an automation. You have a sample report there, and you can actually even ask BSI Clippy if you want even to tell you what's going on with this profile or not. You can say, hey, am I in risk or not? OK? You can remember, ask BSI Clippy. Any questions before jumping into the last part of staying under the radar? Questions? Commands? What is limpas doing? How to use it? Pseudo binaries? Exploiting vulnerabilities? Internet? We have questions? I'm giving you time. Okay, so after this moment, we already gain privileges, we have other ways to enter a computer. We, after all this in the computer, want to stay under the radar. That means once you get access, you want not to be detected, that the people that is going to be detecting you, like you next class. So we are going to be looking at some techniques to actually try to hide what you are doing and not being so loud in here, okay? The first one that we call staying under the radar is that you always need to know who is your opponent. And this is very important in general in cybersecurity, not only in pen testing. When you are with a computer and you want to protect yourself, always consider who is your opponent. Because if your opponent is some hacker in your local network, there are some things that you can do there. This is a picture from Tor, the onion network for encryption, and you can see where each technology may protect you or not. So you may protect from the hacker, but you're going to have the sysadmin of your internet provider that maybe can read your traffic. If the internet provider can read your traffic, it means the police can read your traffic, and many lawyers can read your traffic. So you want to encrypt there. But when you go to the internet and you cross countries, you will have inter-country organizations like NSA that they will be able to access your traffic. And of course, what happened there? And of course, the same situation happened in the country of your destination website. The police and the lawyers and the ISP of your destination website also can access what you are doing. So keep it in mind when you're protecting yourself, okay? Oh, it was moved again. So the first technique of keeping under the radar is hiding your IP address. And for this, we are going to be using a proxy. Who can tell us what is a proxy? And I have a candy, a meme2 candy. What is a proxy?
Some device like between me and the internet that actually can affect my traffic or anything about it. It can scan where I'm going or change even my IP or handle my traffic.
So device between you and the internet that can handle your traffic or manage your traffic, like changing IPs and kind of somehow manage it. Do you agree? Somebody else? Wait, there you go. 1, 2, 3. With you. Oh, well done. Yes.
I think the replay makes it so it looks like you are accessing the internet from the proxy, so it's more anonymous than just accessing the internet without the proxy.
More anonymous to access the internet, or more anonymous than not using the proxies to access the internet, right?
Yeah, because it's only visible that somebody is accessing internet from the proxy, but if the proxy doesn't tell anyone, they don't know it's you.
Okay, so like if the proxy is not telling anyone, they don't know it's you, right? So, there you go, 1, 2, 3. I'm not sure if you agree with this. Oh, I'm sorry. But yes or no? The first thing you need to know about proxies is the following thing. Proxies are not a security tool, okay? Let me repeat that. Proxies are not a security tool. Do not rely on a proxy for anything, thank you, for anything about your security. Yes, they change your IP, but they kind of do it. It's not their main purpose. It's not that they were built for this. So they are not giving you anonymity or privacy or encryption or absolutely nothing. The purpose of a proxy is to manage a lot of connections that wants to go to another computer, usually the internet, and the majority of the cases, they put filters so the company or organization can check who is going where. They can filter sites that you should not be going. They are putting policies in there to control what you are doing. Incidentally, they also change your IP to that of the proxy, but do not rely on this for a very strong security, okay? So they do things like caching, filtering, enforcing policies, Yes, they hide your IP, but you need to know what you are doing to be sure that other things are not leaking, okay? So we are going to be using a tool called TinyProxy to create a proxy, and then we are going to be using proxy chain to chain proxies together in order to attack. So the idea is that you are going to be doing things like port scanning, but instead of port scanning the victim directly, we are going to be scanning through proxies. And then we are going to be changing the IP address. For this, it's going to be okay, okay? So remember that the proxy is opening every connection and unencrypting the connection. When you go through a proxy and you encrypt with TLS, the proxy can open it, okay? Usually because your computer has specific certificates of the company that is putting the proxy, like when you are working for a company. So they can usually open the encrypted connections. I'm not going to go to details here. Just keep it in mind. So let's hide our Nmap scan, okay? We are going to have Nmap, and we are going to be hiding it through a proxy. Nmap, a proxy, and then going here and back. Everything go and back, okay? Clear? Let's move. So 3 components. We need the attacker, that's you. We need a victim, that is going to be a friend. In the case of the internet, it's going to be yourself, like your own SCL, one Docker there, and at least one proxy server, okay? In the CTU case, we are going to have one friend as a proxy, one friend as a victim, you as the attacker, so 3 of us in here. In the case of the internet, the attacker is going to be the hacker lab, the proxy is going to be the Docker that is the class Docker, and the victim is going to be the hacker lab again, okay? You are going to be kind of scanning yourself, okay, internet? Because we are running out of Dockers here. So for the internet, you need to log in to your Docker class, okay? Class container. For CTU, we start here after you already got into the class container, also the internet. We are going to start using the TinyProxy. So let's edit the configuration of TinyProxy to add some lines. All of you, internet after you went to the class Docker, go to the TinyProxy configuration as root, and let's edit this configuration. In this configuration, we are going to say, hey, proxy, allowed all my network to connect, and also allowed the port 80, 443, 8080, and 48443. Okay? Yes? Wait. Too many things confusing. So no public IP here. Yes, there are public. Even if you don't have public IPs, this is a proxy. So yes, your ISP. Imagine your ISP has a proxy, and you are using it. Yes.
Sorry, it's unrelated to proxy. Just the hiding of IPs.
Yes. So when you are connecting from your home through an ISP and then to the internet, everybody knows you. It doesn't matter, because even if you don't have a public IP in your home, this is very weird. But some countries of the world, not here, you don't have a public IP there, they give you like a local network. It doesn't matter because they have logs of everything. So if the police goes to them and they say, I want to know who connect in this hour and time, they go to the logs and they see the local IP and they check which user was assigned and they have your name there. So everything you do in your ISP can be traced back to you if you are not encrypting, right? Or using Tor, stuff like that. But yes, if the ISP has a proxy, everyone using the proxy is going to share an IP. So you have some Anonymity, yes. Just remember that this is not perfect, and it can be easy to de-anonymize you, okay? It's kind of a middle-level protection. Let's go there, right? In this case, we are going to configure your proxy to allow all these clients do all these ports, okay? So you need to go to the tiny proxy configuration, and in any place, whatever, there in the bottom, you need to put these 5 lines. And then please save. This is in your role as proxy, okay? This is in your role as proxy. Remember, internet, you are doing this in the class Docker. You are doing this in the class Docker here. You are doing this in the class Docker, okay? After you did that, you change your configuration, you need to start the service of tiny proxy. So be sure that you have your service of tiny proxy running. Okay? That was your role as a proxy. That's it. Let's move to the second role. Remember, you're going to be a proxy for somebody. The second role, you're going to be a victim. So the only thing we are going to be doing as a victim is actually to check who is connecting to you. So in your Dockers and internet, now you are back in the SCL lab, hacker lab. So internet, you go back to the SCL hacker lab. You create a new tmax call monitor. If you don't have it, you can create it. Create one if necessary, remember. Okay? You already know how to use tmax, so I'm not going to repeat it. And once you are there, we are going to be just using TCP-DAM to show all the packets that are not 22, so you don't see your own connections, that are not the proxy ones. You just want to see the attacks coming to you. Remember, now you are the victim, and you are monitoring who is attacking you. Okay? And then you just leave. Oh, I already have stuff. Okay? Now, the last role, we are going to be the attackers. And for that, please go to the CTU matrix and check the 2 IP addresses of some friends. So please go and put your IP address there. My IP is 172.20.03. So please put something. You need 2 friends, okay? One friend is going to be your victim, and one friend is going to be your proxy. So I'm going to be just copying 2 of these ones. And I'm going to be putting, like, here is going to be my victim. It doesn't matter. I'm just making a note. And now I'm going to be taking, I don't know, this one. That is going to be my proxy. Just this is for me to have something in mind, okay? Just remember that you need 2 IPs. For the mock students on the internet, your proxy is going to be your class Docker 099, and your victim is going to be your hacker lab, okay? Now that you have your IP, everybody, let's do the attack. How do we do the attack? We are going to be using a tool called proxy chain. So as an attacker, in your Docker container or in your hacker lab, you need to edit this file, proxy chains, and be sure of 2 things. First, that you don't have the line SOX4, and that you have a line with HTTP, the IP of your proxy, 8888. Okay? So my proxy IP was 090. So I'm going to go and put 090 as my proxy. See? There you go. I'm going to give you 30 seconds to catch up. We are attacking now. We need to configure the proxy chain. And in the proxy chain configuration, we need to delete this line. And we need to add a new line with your proxy IP. Internet, you are doing exactly the same. In your hacker lab, proxy chain, delete the socks, add the HTTP. Okay? I will give you some time. Beep, beep, beep. Questions? Now that you have it, we are going to be using the tool proxy change, and we are going to be doing an nmap specifically of those ports, because those are the only ports we enable in the proxy chain. We can do for any port, but let's use this one. And then you scan your victim. When you do that, you will see that proxy chain is using the proxy, using the proxy, using the proxy, and yes, those ports are closed. It doesn't matter now, but you just did a port scan to a third computer, and that third computer did not see which is your IP address. If you want to check, you can go to your Tmax monitor. Remember, you have it here, and you will see that you have connections from some computers, but none of these computers are the real attackers. They are proxies. And the people on the internet is actually proxy chaining many of these ones on the internet. So they took over 100 computers, they install the proxies, they make a chain, and then the packets go through 10, 20 computers, like in the movies. And that is actually making very hard to know which was the IP of the attacker. Did it work for you? Did you scan? Did you see the closed ports? Did you see the monitor, internet? Congratulations, you just did a very advanced port scan through proxies on the internet. And yes, you can also search for free proxies on the internet and use them, no problem. And more things there for you to try. Okay, after using a proxy, we can actually use now a VPN to make this same change. So we are not going to be using a VPN technically, but just be sure that you know which VPN you are using to hide your identity. There are many VPNs in the world. We know that you use VPNs often, so we are not going to go here very, very deep. The only thing I'm going to say is that extremely few VPNs providers on the internet are really, really private and secure. Yes, they encrypt, but the VPN provider can still see your unencrypted traffic. So when you use a VPN, the people around you cannot see the traffic, but the VPN provider can. And even if you super trust them because they're super well known, in most countries of the world, when the police comes and says, I want the logs of that person, it's mandatory to give it to them. They cannot refuse. So any VPN provider of the world, when the police comes, they will give your logs to them, which means you are not really secure. So using a VPN is a little bit better. It's not completely secure, okay? The people that is doing real attacks are not only using VPNs. Questions about this? VPNs? Yeah. If you sell? Self-host a VPN in some provider, yes. Much better, yeah. Yeah.
Because I know that when we self-host on Oracle or something like that, we suddenly have IP that is public, and theoretically, if someone asks Oracle whose traffic is this IP, they should be still able to trace it to us.
So the question is like, if self-hosting a VPN is better or not, and in the case of provider like Oracle, what the police can do. everything depends how much access they have. If this is a VPS, this is your own computer, you can set up a VPN in a way that only you have really access. And even if Oracle wants to get in your computer, if you do it properly, there is no way they can see what they did in the past. They can see the traffic going in and the traffic going out. But if you change your IP using a proxy or Tor, then your VPN, and then you get out, there is nothing tying the VPN connection to you. Now, if you connect to the VPN server from your home directly, yes, they will know it's you. They don't know what you did, but they will know that it was you.
Okay.
So is it safer? It is safer. Is it safe? Maybe. Like, you need to be very careful when you're dealing with this, right?
Okay.
So it's actually a very good question. Pay attention when you're having this, right? Like if you are using Tor or a VPN or what. So talking about Tor, Tor is one of the best things that you can use for this. Who here is using Tor? Tor users, there you go, Tor users, very nice. Anyone running a Tor server, middle server, exit node, nobody, internet? It's a shame. You can run Tors in any computer, and you can contribute to the network of anonymity for everybody, and it's safe for you if you are not running an exit node. So very fast, if you don't know, Tor is a network that routes traffic through a volunteer amount of servers, and it's usually only using 3 computers, 3 relays. And the way it works is that when you encrypt, you're actually encrypting 3 times. And the first relay is opening the first encryption, but cannot open the other 2. So it's giving the traffic to the second relay. This second relay can open the second encryption, but cannot see the last one because it's another layer. The third relay opens the third encryption, and then the traffic is unencrypted and goes to the internet. So nobody in the Tor network has enough information to open your traffic. And these relays are randomly picked in the volunteer network. So you cannot just pick 3 of them and make it happen, okay? So this is how it works, the entry node, the middle node, and the exit node. I'm talking in the very, very simplest of the Tor setups. They are much more complicated, okay? So we suggest you use Tor as much as you can, Tor browser or anyone. There are many tools around, including Toring nmaps or everything you want, right? So remember, strong anonymity, yes. Hides your IP and location, yes. Usually used for synchronizing censorship, also good. Decentralized, no problem. The cons, apart from the traffic that now is not so slow, it's that the exit nodes can still see your unencrypted traffic. So be careful there, okay? The exit node will see your unencrypted traffic because confidentiality is not the main purpose of Tor, okay? It's privacy. However, there is no total privacy because you can log into your personal account. And the moment you log in your personal account and you put your username and password, the last exit node will see that, and that's it. They can actually, from the web page, give you cookies, and they're going to track you. So be very careful what you mean with this, okay? Questions about Tor? Internet questions about Tor? Hiding the way you connect to a computer, proxies, VPNs, and Tor. We are going to stop in these 3 and not the rest of those. And finally, we are going to go to how to hide your activities in the computer you are attacking. Because you go into the computer and you are typing and you are doing things, but we don't want the defender to actually find what you are doing. We are not going to go very deep into these, very basic techniques, but you need to know them. The first one is the bash history. When you connect to a computer, and in this case, you are going to be doing this from your Docker container or your Hacker Lab, please, you can check which is the history file that your computer is using. So in every Docker, when you check the variable called hist file, you will see where is the bash history that you are using. This bash history is the file that has every command that you type in your computer every time that you log in. So this is one of the main ways a defender is checking what commands were used in your computer, okay? You can actually see even the content of the file with the his file, okay? This should work for Internet SCL2, so you have all the commands ever done. Check that you can see those. You have another command called history, where you can see the last 5 commands, for example. So be sure that you find those and you see. Okay? You can see what everyone was doing in your computer. And those are the 5 last commands. Also, you can see the content of the file until the last 5 commands, right? So that is another way of doing that. The question is, why, if I'm looking at the 5 last command in history, I see these 5 things, and when I'm looking at the file itself with tail, I see other 5 things? Who can tell me why they are different? They are the last 5 commands anyway. Why these 5 last commands are not these last 5 commands? And the reason, because, yes, the write to the file happens when you exit. Are you ready? 1, 2, 3. I'm calculating. Look at that curve. So exactly that, the file is saved the moment you exit the shell. But the history command takes all the real commands that are in memory, let's say, in a way, up to now. So the way you are actually forcing, now as a defender, you are forcing the story of the commands to bash history at any time, the moment you press enter, is by putting this specific line in your bash RC, that is the configuration of your bash. So when you do that, after that moment, every command that you do is automatically saved into the file. And this is what you want as a defender. So nobody can type, and then leave, and you don't have anything in there, okay? So you can also delete commands if you are an attacker. Sorry, delete histories of commands, okay? And you can use the idea of deleting the history as an attacker to execute a command, echo discrete, and then delete the last line in the history. So when you do that, history delete, history 1, you execute a command, but that command, history, is not going to be saved in the list of commands. So as an attacker, you can execute commands and automatically delete them from the history list. Okay? That way, you are going to be hiding your traces. Yes?
Is this vulnerable to, like if I run 2 commands in 2 shells, and the first command is a long-running process, then the deleting, will it delete the previous command, or the one that was actually written?
It's going to be the one of this shell, because they are in memory, and these are not in the file, right?
Well, if I enable the immediate write-back.
Yes. Then you need to delete in the file, and then it's whatever you delete. But this is not this command. It's going to be deleting a file. So you have to open the file, delete the language you want, and exit. And that's going to depend who was faster, right? So if you are putting everything in the file, and then you go to the file and delete the last line, it's going to be up to you, right? You need to check that one. So one way to actually, imagine you log into a computer and you start typing, attacking. Oh, and you forgot. Shit, all my commands are going to be stored in the file the moment I exit the shell. Imagine that they are not saved automatically, they are saved when you exit. How do you exit without leaving the commands in that history? And you can do a small trick with kill, that you kill your own bash and the moment you kill your own bash, it's exiting by force, and it's not storing the commands in the registry. So that's a very nice way that actually I learned from a botnet doing this, of how to exit a shell without leaving the commands. Okay? Questions? No? So, yes, if you want to do this permanently, you just stop the bash from storing commands with his file being dev null. Apart from hiding commands, we can hide processes. And processes are a way that I'm just going to show this. I'll leave it to you later. But this is the magic of the execution of the commands, where you are, instead of just running nmap, look at this, instead of running nmap, you are running nmap and changing the name to whatever you want. So when you run a program with exec, you can choose the name of your process. And then instead of nmap, you just call it whatever. And then the moment somebody's doing a PS, it's going to check if a file, the name of a process is going to be something like, sure, everything fine. Or actually can be empty, like here, okay? I'm going to be leaving this sorry, for you as homework, okay, Internet? How to change the name of your process. The same here, hiding a tool. Okay? So, to close the day, please, 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 CTU students, remember to delete all the things you did today, the user, my big team. Get out the sudo, because if not, anybody in your computer will be root, and you don't want that. Remember to defend your Docker, delete this one, delete the permissions in Python. If you are using other tools, also delete everything, check your processes, cron jobs, stop the proxy, please, 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 okay? If not, you are going to be vulnerable, and then some student may get in. Questions so far? To finish? Internet? Questions? Hiding processes, hiding your commands, VPNs, stores, set user ID, sudo, privilege escalation, maintaining access, remote shells, reverse shells. No questions? Sure? The name of the dragon? No, you don't know that one. Okay.
There is a question.
Oh, there is a question.
From a defense point of view, how do you detect processes with the name changed?
From a defense point of view, how do you detect processes with a name change? I will go that only from this output, right? Only from here. So imagine, very fast, right? Imagine I'm doing this command. Look at this, right? That is doing an nmap with another name, right? I'm going to run this from the attacker, right? I'm going to run that, and then I get out, and I do my PS. Can you see what is the nmap? Well, it's here, right? So the problem is that if there are no parameters, or you don't know what you're looking at, this can be anything, including PS. The name of the process can be bash, can be, I don't know, maybe the name of it should be cron. This is a very good one, cron, right? Or GPG agent. So I would say from looking at the process list, nothing you can do. Now, if you analyze the context, like, oh, why there is a bash running that process? If you pay attention, in the process, in the daemons of the system, there are no bash that is executing them. They're running in the background. But the programs that are executed by hand, they have a bash on top. So maybe you can analyze the structure, process that have a bash, process that are new, things like that. But from the name, can be whatever you want, including empty. And it's very funny, because when it's empty, it's extremely hard to know what to kill, because you need to find the ID, and then the empty is at the end, and things like that, right? There are many malware in Linux that are putting empty names as a process, and you lose them very, very fast. So I would say monitor processing, running like usually some type of antivirus or software like that. Usually they check the processes, but that's it, right? And then by hand. Questions from the internet? More? Please don't forget to clean your Dockers. And I think we are done. Going into assignment. Assignment 6.
Yes. So tonight, fun 1-2-parter. So you will, in the first part, have to gain access to a computer, and then you will have to make sure you stay in that computer, so you will have to kind of gain persistence as well. And the second part will be escalating your privileges to get some higher privileges to, well, you will see what you will need to do. But basically, it's kind of a whole range of attack. Get in, stay in, elevate. And it's 5 points. At 9.
At 9
p.m.
p.m. Questions about the assignment? Anyone having issues with the assignments? No? I know that you're asking and they're answering. Something more? 2 things. First is remember that if you want to vote, and we hope you want to vote for the last class, send us a postcard. We are waiting for your postcards, internet. Go there. You don't have to be fancy. You can take a blank paper, put the address, put some drawing of the stamp, put a stamp and send it. Even in Czech Republic, I know that you can send a postcard all over the country, or maybe Europe without paying, right? You send student to student, so you can send those. And we are looking forward for your postcards. And please, feedback, people. Remember, only 30 seconds. There are many side dishes today, many side dishes. We didn't want to overdo the class. If you want to get deep into the topics, go. There are many nice things there for you to learn, okay? There are many explanations. I thought they were talking. You want to tell me something more? Nothing more, people? Okay, so thank you very much. Happy Halloween. Feliz Dia de los Muertos. Vesele Dushiki. Ne, you don't say Vesele Dushiki. Ne. So if you are celebrating Dushiki, the second you can do also, whatever you do. And see you next class, people. See you. Bye-bye. Enjoy. Hi. Ciao, internet. Ciao, ciao. Ciao, ciao. Oh, yes.